All right, today we're going to be getting started in Chapter 1, taking a look at the first section here in Chapter 1, and we're going to be looking at what's called linear equations, solving different kinds of linear equations of all kinds here. But before we get into some examples, just some definitions that I need to make sure that we're on the same page about. All right, so first of all, when we talk about an algebraic expression, right, an algebraic expression is just something that uses variables, numbers, or operations. And by operations, I mean addition, subtraction, multiplication, division, square roots. All right. So some examples of some algebraic expressions could just be a variable like x. That's an algebraic expression. It could be a number like 3, or it could be any sort of operations between numbers and variables. 3 times x, x plus 3, the square root of 3x. All right, any of those are what are called algebraic expressions. Now, an equation, which is what we're going to focus on in this chapter, and probably a term you've heard quite a bit before, but the definition of equation that I want to work with is just a statement that two expressions are equal. So an equation is a statement that two expressions are equal. So for example, if I have one algebraic expression, 5x plus 3, and I have another algebraic expression, negative 3x minus 9, if I set those equal to each other, that's an equation. And when we talk about solutions of this equation, we're simply talking about what values of the variable, what values do I need to put in for x to make this equation true. And when we talk about equivalent equations then, equivalent equations are just equations that have the same solution. So two equations that have the same solution. So for example, one equation might be x plus 6 equals 8. This has a solution of x equals 2. Again, because that's the value of x that makes this equation true. So 3x equals 6. That also has a solution of x equals 2. So we would call these two equivalent equations. And then finally, this idea of linear equations in one variable. Linear equations in one variable are any equations that I can write as ax plus b equals 0, where a and b are just numbers, just any real number. The only restriction to that is a can't be 0. Because if a was 0, you'd have 0 times x, and now you don't have a variable at all. Now let's take a look at actually solving some equations. Some of this I'm going to anticipate you've seen before. Some of it might be a little bit new to you. So if we have an equation like this, again, solve the following equation simply means tell me what x needs to be that would make this equation true. This is what I call a two-step equation because it's got multiplication and addition in it. Now, I like to draw a line down the middle of my equation, and by the middle, I mean right through the equal sign. Because I'm going to be working on both sides, I like to think of equations like a teeter-totter that I need to keep perfectly balanced. Now, order of operations says we do multiplication first and then addition. But we're kind of undoing this problem, and solving equations is all about doing the opposite. So I actually want to do order of operations backwards. So I want to take care of that plus 4 first. I want to get rid of that or eliminate that by subtracting 4. Because if I subtract 4, that makes that 0, and that's perfectly okay as long as I keep it balanced by subtracting 4 on the right-hand side as well. So what that gives me now is 3x plus 0, or just 3x, and 16 minus 4 is 12. And what I need you to catch, one of the big ideas I need you to see here, is that 3x equals 12 and 3x plus 4 equals 16 are equivalent equations. They both have the same solution. because I did the same thing and did it to both sides. And now I want to get x by itself here, so I'm multiplying by 3. To get rid of that, I'm going to divide by 3. I do the opposite, and really that makes a 1 there. And that's perfectly okay as long as I come over here and divide by 3 on that side as well. So I get x equals 4. And that's a solution to this equation. I can check it real quick because that should make the original equation true. 3 times 4 is 12, plus 4 is 16. We found the value of x that makes that original equation true. And on any of these, if you want to give them a try first, hit pause on the video. You're more than welcome to do that, and then go ahead and press play and see if your solution matches mine. This one's a little bit more involved. Looks like we've got some distributive property. I'm going to put some 1s in front of there. And again, I'm reading this subtraction as a negative sign, all right, all the way through. So now I'm just going to distribute. So the 5x just comes along, and I've got minus 7x and plus 4, negative 1 times negative 4. And I've still got the minus 2. And again, I should have drawn that line right down the middle there. And here I've still got the 5, and I'm distributing negative 1. So that would be negative 3x minus 2. Now, before I worry about both sides and doing things to both sides and getting x by itself, I like to look at the left-hand side and see if there's any like terms I can combine to clean that up a little bit. And I've got 5x minus 7x. Those are like terms, so I can combine those. And I've got a plus 4 and a minus 2, or you might look at it as plus 4 and plus negative 2. Regardless, I can combine those to plus 2. That equal sign just continues to slide right down that line. And here I've got 5 and minus 2, or if you want to think of it that way, it's a negative 2. I've got 3 minus 3x. And again, this equation is equivalent to this equation, which is equivalent to this equation. We're just cleaning this equation up, making it a little bit simpler step by step until we get x by itself. Now I've got an equation with variables on both sides. All right, I've got to get rid of one of them. I usually go after the smaller of the two. It doesn't matter which one you go after, but that's the process I'm going to follow. So again, I'm looking at this as a negative 3x. This is a negative 2x. This is smaller, so I'm going to get rid of that. And to zero out negative 3x, I'm going to add 3x. And that's perfectly okay to do as long as I come over here and add 3x. Because again, if x is 6, I'm adding 18 to both sides. If x is 5, I'm adding 15 to both sides. I'm adding the same thing to both sides. And notice where I wrote that. I wrote it underneath the like terms. So now what we get, negative 2x plus 3x is 1x plus 2 equals, this makes 0. So all I have here is 3. And now this is really just a one-step equation. Subtract 2 from both sides. You could divide by 1 if you want to, but I get x equals 1. And then finally, this last one on this second page, I've got some fractions involved here, but that really shouldn't affect the way that I do things. Again, because we should be able to handle fractions, or you've got a calculator that does that for you. Again, there's no like terms to worry about on either side, so I just look and see I've got variables on both sides. I get rid of the smaller of these two, and 1/2 is smaller than 3/4. So if I want to zero that out, I can do that by subtracting 1/2 p, and that's okay as long as I do it to both sides. 1/2 p minus 1/2 p zeroes out, so I get 0 minus 5. I got negative 5, and 3/4 p minus 1/2 p. You can use your calculator. You guys might be able to do that one in your head. That's 1/4 p. And now I'm ready to get p by itself. This is multiplication, so I want to divide by 1/4. That'll make that 1, and that's perfectly okay as long as I come over here and divide by 1/4. So I get negative 20 equals p, or we could read that p equals negative 20. All right, so a couple more here on the third page, and now we're looking at what are called rational equations. Rational equations are equations that involve ratios or involve fractions. So we look at this, and I see a bunch of ratios, a bunch of fractions. I'd love to clean that up, and I can do that by looking at what's called the lowest common denominator. So if I look just at my denominators, 3z, 2z, and 3, I want to find the least common denominator of that, or the smallest thing that all of these will go into. So again, I see a 3, I see a 2, I know both of those will go into 6, and then I've got a z. All right, so I think my LCD is 6z. And what I'm going to do is multiply that entire equation by 6z. So I'm just going to write this out. I'm going to take my time. It's almost like the distributive property. Again, I'm just doing it through an entire equation. So I get 6z over 1 times 2 over 3z. So that's just 6z times the first thing that's in there, plus 6z over 1 times 1/2, 6z times the second thing that's in there, equals 6z over 1 times 4 over z, plus 6z over 1 times 4 over 3. So again, that was just distributing through 6z, and that 6z came because that was my least common denominator. But now watch what happens if I look at some things I can cancel. So 6 and 3 are both divisible by 3, leaving 1 and 2. And I can cancel out those z's. So 2 here, what I end up with is just 2 times 2. That's just 4. Plus, what can I cancel here? Well, 2 and 6 are both divisible by 2. So I get 3z times 1. That's just 3z. Equals, my z's cancel out, and all I'm left with is 6 times 4. That's 24. Plus, and 3 and 6 are both divisible by 3. So 2z times 4, I get 8z. And what I have now, again, is an equation equivalent to this one, which is equivalent to this one, but a heck of a lot easier to solve. No more ratios. So now I've got an equation with variables on both sides. I get rid of the smaller one, that's my 3z. So I'm going to get rid of that by subtracting 3z. That'll zero that out, and that's okay as long as I come over here and subtract 3z. So that's going to give me 4 plus 0, or 4 equals 24 plus 5z, negative 8z minus 3z. But now I've got that two-step equation. Subtract 24. I'm kind of running out of room here. So I get negative 20 equals 5z. And then divide by 5 on both sides. And I get z equals negative 4. And then finally, the last one here, this is another rational equation. I look at my denominators. I've got x minus 2. They're both x minus 2. So what I'm going to do is multiply that entire equation by x minus 2. So let me write that out. X minus 2 over 1 times 2x over x minus 2 minus x minus 2 over 1 times 3, and I'm going to write that 3 over 1 just to be consistent, equals x minus 2 over 1 times 4 over x minus 2. Again, all I'm doing is just distributing there. And now I start looking, what can I cancel? They both have an x minus 2, so all I'm left with there is 2x. Nothing to cancel here, so I've just got, and I'm going to put the 3 in front. Since it's multiplication, I can switch that around, so I've got 3 times x minus 2 equals, and x minus 2 in common there. All I'm left with there is 4. And now take a look at this equation I got left. No more fractions. But it's equivalent because I multiplied the entire equation by the same thing. Now again, I'm going to look at this as a negative 3. I'm going to look at this as a negative 2. We've got distributive property going on here, so here we go. 2x plus negative 3x plus positive 6, negative 3 times negative 2, equals 4. Before I start moving stuff, I've got some like terms here. All right, 2x and negative 3x is negative 1x plus 6 equals 4. Two-step equation. Subtract 6 on both sides. I get negative 1x equals negative 2. Divide by negative 1 on both sides, and I get a solution of x equals 2. All right, so what I'd like you to do, got this homework here on page 99, all sorts of equations to solve. Make sure you're showing me nice work here. If you have any questions, feel free to go back to this video and get those questions answered. Talk to your classmates, come talk to me, but go ahead and work on page 99, those questions, please.